Okay everyone, this is the second half of the review for the cumulative test that's coming up on Thursday. At this point, again, just to remind you that this review packet is only for the newest material that will be on the test. Your old test has questions on it that will show up again on this one because it has to be something cumulative for the whole year so far. That's why we're splitting it up into 2 days now, because we have enough content here that it's going to take more than 1 day to test on it. Alright, so what's nice about this last part is I think these are quite a bit easier than the other part of this review packet was. So hopefully these rate of change ones and some others will be kind of the easier parts. Alright, it says, which of the following situations represents a linear relationship? Okay, so linear is the key word here. What linear basically means is that every interval, or every time something happens, it does the exact same amount. So I'll show you what I mean. Alright, let's say a town loses 1/2 of its population every 10 years. Okay, if we made a quick chart of what was happening there, right? Let's say that at 0, at the beginning, I'm making a quick chart so you can see what this would look like. So at 0 years, let's say that population was 1,000 people. Okay, pretty small, but it started at 1,000 people. Okay, every 10 years, so 10 years later, it says it loses 1/2 of its population. That's down to 500. After another 10 years, so in 20 years since the start, it's down again by half. That's 250. Okay, do you see how here it went down 500, and then here it went down 250? That right away is not linear, because linear would mean it would be going down by 500 over and over again. So this idea that it loses half every 10 years, that's not really linear, because what's happening is you're losing a different amount every year. Linear means you would lose the same amount every year or gain the same amount every year. Alright, so let's go to part B. So A is definitely not right. Population of a town increases by 1,000 people every year. Okay, that's the key phrase right there. What's going to happen? Every single year it's going to go up by 1,000, which means the change will always be plus 1,000, like this. I think maybe you guys remember when we did these, where you had to look and see whether it was linear. If the change is always the same, it's linear. That one is definitely a linear function. So this answer is B. Okay, let's go to the second one, rate of change, number 17. It says, which statement describes the rate of change of the following function? Okay, when we talked about rate of change is synonymous or means the same as slope. So when we see which one describes the rate of change here, well, the slope is 3. And it's always 3. So when we say it's 3, it's not going to change from 3, it's always 3. So when it says the function has a varying rate of change, that means changing. It's not C, it's not D. These are linear functions, which means that their rate of change is always the same or constant. So the only question is it changing at a rate of 3 or changing at a rate of 7? Okay, well, what's the slope? The slope is 3. So it is A. Alright, last one on this page, number 18. It says the graph shows the population P of a town after T years have elapsed. What is the annual rate of growth in the town? Okay, well, let's see. It starts at 30,000, and it's kind of hard to judge, but if you go over 1 year, you're up here. It looks like it's somewhere in the middle of 30,000 and 35,000. But you're not 100% sure. So if we go over the 2 years, though, to right here, that's right at 35,000. So that means in 2 years, it went up 5,000. Okay, so if it took 2 years and it went up 5,000, how many people is that for every 1 year then? Well, it goes up 5,000 in 2 years. It means, in theory, they went up 2,500 in 1 year. Just reading the graph a little bit. Okay, number 19 is probably the easiest rate of change problem you'll ever see, but I've seen this on the Keystone, so I'm hoping this is a really easy one. Okay, it goes through and tells you all about how she bought several bags of candy and whatever, and they contain different number of pieces of candy. Whatever. Okay, so if we look at it this way, and it says identify the cost of one piece of candy. Well, I mean, okay, so in the first bag she bought, there were 5 pieces, and it cost $3. So I think you guys can figure this one out. 5 pieces cost $3. How much does one piece cost then? Well, it's not $3, and it's not $1.67 either. If they were $1.67, you'd never get 5 of them for $3. All you do is take $3 and divide it by 5. You're going to get 60 cents. D. See, the reason why this fits in the rate of change things, just so you know, is each one of these goes up by 5, and each one of these goes up by $3. That's a linear rate of change. That's a constant slope, is another way they would say it. But the question was a lot easier than that. It just wanted to know what is one cost of a piece of candy. Alright, number 20, my favorite question on this whole thing. What I love about number 20 is that you don't even need the problem. Really, we could give you this question and just start right here with which statement is correct. Since it's there, let's look at it. It says the amount of fuel in gallons in a vehicle's fuel tank after driving m miles is 25 minus 0.05 m. So it's saying that if you want to know what the total fuel is left in gallons, start with 25, and then for every mile you go, subtract 0.05 gallons. So you'd put in the number of miles here, and you would know how much fuel you have left. But look at the word problem part. It says, for every mile the car is driven, the amount of fuel increases by 0.05 gallons. Imagine that. Every time you drive your car, the amount of fuel in the tank goes up by 0.05 gallons. Even better yet, look at B. Every time the car is driven, the amount of fuel increases by 25 gallons. Could you imagine that? What kind of awesome car would that be, that every time you drive a mile, you get 25 gallons of gas in your tank automatically? It's crazy. I wish, but not true. A and B, definitely not true. It has to go down, right? The gas has to go down. Alright, so let's look at C then. C and D, maybe they're both right. Well, who knows? It says every mile the car is driven, the amount of fuel decreases by 25 gallons. Okay, think about that for a minute. For 1 mile, it costs you 25 gallons of gas. That's what it says. For every time you drive the car a mile, the amount of fuel goes down 25 gallons. I don't know what kind of vehicle you're driving, but tanks get better gas mileage than that. So it's definitely not losing 25 miles or 25 gallons every mile. So you're going to lose the 0.05 gallons. That's 1/20th of your tank of 1 gallon per mile, if you think about it. That's a lot more reasonable. That means to use 1 gallon of gas, it would go 20 miles. That's what it really says. That's realistic. But even if you don't see that, what you can certainly see is that it's not going to go up, and it's not going to decrease by 25 gallons after 1 mile. So they're really kind of giving you a common sense question there that you don't even really need that part for. Alright, let's look at the last lesson of this thing, which is on best fit lines. The reason why we put this here is not so much because we're asking you to draw best fit lines, although you might have to. It's really about being able to write an equation from a graph, which you guys have been working on a little bit. It just hasn't necessarily been with scatter plots, but it doesn't matter. It's still a linear equation. So you get all this stuff up here in the information, then it says, here's the graph, and it says the graph above shows a line of best fit for data collected on the size of green bean harvest in relation to the amount of rainfall. What is the equation of the line of best fit? Okay, well basically they're asking you to write an equation for this graph. The only thing you want to watch out for is these numbers over here. It says they're in the thousands. So this is not 1, it's 1,000 and 2,000 and 3,000. So they were sort of shorthanding the way they write the graph. But we need to read a graph, to write an equation, we need a y equals mx plus b equation, which means we need a slope, and we need a y-intercept. Both of which we can read off the graph. This is what makes graphing so nice, is that if we want the y-intercept, the number on the end, all we need to do is look at where it touches the y-axis, which is right here. That point right there is the y-intercept. So where does it touch? It touches at 1, but remember that means 1,000. So its y-intercept is plus 1,000. So already we eliminate B and D as possible answers. So then the question is how do we get a slope then? Well, okay, we have to read it as a rise over run. So you need to pick a point off the graph that you can easily see. How about right here? Right on the line, right at the corner, and we'll count from the y-intercept over to it. We go up 1, but remember it's not 1, it's up 1,000 and over 1. So our slope, rise over run, is up 1,000 and over 1, which reduces to just 1,000. So this equation, the slope goes here, so we have 1,000x plus 1,000. The answer is A. So this one asks you, can you read a graph and write an equation, but it also asks you to pay attention to detail that these are not by ones, they're by 1,000s. A lot of people put D as the answer for this because they see the y-intercept as 1 instead of reading it as 1,000, and also then count rise over run as up 1 over 1. And so a lot of people put D because they're not paying attention to the fact that this is by the thousands. Okay, let's look at number 22. So they drew a best fit line on there again for us. It says a small theme park is trying to determine the number of guests they should expect on a weekend based on the temperature outside. So you can see the temperature's on the bottom and the number of guests, again in the thousands, is on the y-axis. So it says based on the trend line, that's the same thing as the best fit line, about how many guests should be expected if the temperature is around 90. So you can see that the line they drew is right here, but they stopped it right there. The 90-degree temperature is over here. So if you want to know what it would be, just take a ruler or something nice and straight and just trace over the best fit line and make it longer. There's your best fit line. So what is 90? If I go up from 90 and then I trace it over, if I had to guess what's the right number, it looks to me like 9,000, maybe just a little bit higher than that. Well, it's not 9 because it's not 9, it's 9,000. So it's either 8,200, that's probably too low. It's definitely at the 9 or higher. And I don't think it's quite 99 either. It's not really right next to this top number here, which would be 10,000. So I'd have to pick 92,000. But you see, they didn't draw the best fit line long enough, so what do? Draw it long enough for yourself to see it. Okay, let's go to number 23, another best fit line one. It says, looking at the graph above showing a line of best fit, what is the correlation between x and y variables? Okay, well we would call this a negative correlation, right? So if we read it like this, as the glasses of water goes up, what happens to the amount of weight gained? Well, if you look at the graph, right? As the glasses of water go up, this goes down, right? When it was 1, it was like right around 7. When it was 2, it was closer to 6. 3, a little less than 6. So as these go up, the number over here goes down. That's what a negative graph means. As x goes up, y goes down. So when we see it this way, if x goes up, x increases, y has to decrease. That's C. So we want to look for the one that says x goes up and y goes down. Now see, if it was positive, if the line was going uphill, it would be the exact opposite. As x goes up, y goes up. Okay, talking about time to melt certain temperatures. It says Tara graphed how long it took a cube of ice to melt at certain temperatures. What is the equation of the line of best fit above? So here again we're asking, what is the equation of this line? Okay, well, I look at it one way. First thing I see is I see a downhill line. Okay, downhill line. That means negative slope. So I come over to my equations, knowing that the number next to x is the slope. It has to be negative. Well, they're all the same except 2 are negative and 2 are positive. So B and D are no good because they're positive slopes. So it's either A or C. Then the other thing I look at is the y-intercept. That's the other thing I'd need, and that's where it touches the y-axis. So I go up and I look at the y-axis. Where does it touch? Right there. So that's positive 8. So which one of them has a negative slope and says it touches it positive 8? That's what this means. This one. Okay, we're on to the last one we have. This one can be kind of a pain because you're going to have to do a little bit of drawing, but I think before you do anything else, you should try to eliminate some potential incorrect answers. So it says, which scatter plot most likely has a line of best fit represented by y equals 2x plus 1? So instead of drawing the line of best fit, they tell you the equation for it, and then they're asking you to look at those 4 graphs and figure out which one of those 4 graphs would have a best fit line, like the ones we've been working with. A line right through the middle of the data, a best fit line that would have this as an equation. Alright, so what I would say is, to me this says positive slope. So with positive slope, it means that my line of best fit would have to go uphill. So I look at the graphs that I have here, right? If I look at Z, I see like the zone of data that I have is like right here. You see what I mean? Like that's where all the points are basically at. If I were to draw a line through the middle of that, I'd have a best fit line kind of going like this. To me, that's downhill. That's a negative slope. So I need a positive slope graph. So it is definitely not Z. No. So I go over to the answer choices, and Z is not one of them. I also look at this graph, X, and again, if I highlight where the data is located, it's in this zone right here. And again, if I were to draw in the middle of that zone of data, my best fit line is still going downhill. So it's not this one either. So I can go down here and get rid of answer choice D. So I'm left with Y or W. Okay, this is where it gets a little tough because you actually have to draw the best fit line in. So here's how I suggest you do it. Looking at the data that you have, okay, basically what I would suggest is try to zone off that data like this, keeping the kind of general angle going. See what I mean? Like that kind of encompasses all of the data that's there. And then draw your best fit line right through the center of it. Like that. So it is uphill. So it might be that one. We'll take a look at it in a second. And then the other one, I would say it looks like it goes over here somewhere. Trying to get all that data in at the angle that it fits. Something like that. And then draw the best fit line in the middle of it somewhere. Okay, so we have one that says the equation says it should hit at +1. But where we estimated these things to graph at, it looks to me like neither one of them really touch at 1. This one definitely doesn't. This one touches maybe at like 0.5 the way we drew it. So using the y-intercept, although it's a good tactic, it's not really going to help us here because it's too hard to tell what it really is, and we really estimated where those lines go. But let's look at slope for a minute. Remember, slope is basically rise over run. So if you look at this graph, right, and I start here and I go up 1, 2, like let's say I want to go from this spot to this spot on the line that I drew. I'm going to go up 1, 2, and over 1. That's a rise of 2 and a run of 1. That means the slope is 2, just like the one I wanted. So I'm thinking that it's probably that one. Just to make sure, let's look at y. I'm going to pick a point here and I'm going to find another one somewhere. Maybe like right here. 2 points that I could kind of see what they are. I would go up 2 and over 1, 2, 3. This slope is 2 over 3. It's not even close to 2. Right? 2 is way bigger than 2/3. So it turns out that this one is the correct graph because the slope is definitely closer to 2 than the other one is. So our answer to this one is W, or answer A. Okay, that's it for this review.